working on giraffe, and of course, giraffe is today present in a very large part of sub-Saharan Africa. So during almost 2 centuries of taxonomy of the giraffe, there have been many different taxonomic schemes on how many species we have and subspecies. It's still not resolved because some people say that there is only 1 species, but some people say that there may be up to 11. So there is a huge disagreement on that, and of course this is very important for the conservation of the giraffe, because we have to know exactly which species are where so that we can know how endangered they are. So there are, results out of taxonomy that some people don't imagine. So what we are trying to do with the Giraffe Conservation Foundation is that we are trying to clarify the taxonomy of the giraffe using different approaches. So, of course, the colleagues there have worked a lot on genetic and ecology studies. And now we have started this project on the 3D geometric morphometrics on the skull of the giraffe, because the skull of the giraffe has some very distinct features, these little horns that are called ossicones, which are very different in the range of the giraffe today in Africa, and they can possibly differentiate species. So that's our basic idea, that we will use the overall shape of the skulls to see if there is a correlation with already reported species based on genetic data. At the moment, we have used 2 different ones, and both of them are very simple. We thought that it wouldn't be a good idea, at least as a first step, to add a lot of different landmarks, to fill the skull with landmarks. For the moment, we thought that it would be better to pinpoint structures, the structures that we see as different between the different forms. Here is a skull of a northern giraffe, a male one, and you can see this middle ossicone above the eye, okay? Mm-hmm. Which is relatively tall in comparison to what I will show next. This is a Maasai male giraffe, and you can see that this ossicone here may be enlarged, but it's not tall. It's like a bump. So that's the main difference that can differentiate some different forms. So that's what we wanted to quantify. Also, the ossicones are different between males and females. So these were males, and this is a female. So you can see that there is practically no or a very, very faint ossicone there, and that the other ossicones at the back are far smaller. So these are the most basic differences that exist in the literature. So this is what we wanted to check with our landmarks. So I have here 4 skulls open. 2 of them are females and 2 of them are males. And one of each is with one of the landmark protocols that we have. So first, and the easiest and the simplest protocol is just the eye, 3 landmarks on its orbit that can actually tell us a bit about like a stable plane. And then just 1 landmark in here, a contour for these ossicones, and then another contour here, because also the occipital region is important. So this is a female skull, and this is a male skull. Again, this is the restricted protocol, which has worked really well for the moment. Let me stop sharing this, because we already have some preliminary results. So you can see this here that we made with our first specimens. So the blue ones are the males and the green ones are the females. So this is a very clear differentiation. And then we already see some patterns in the males. So you can see here the 2 extremes. This one, the ossicones are converging, whereas in this end, the ossicones are diverging. And this was a young one. That's why it's closer to the females. So yeah, that's the simplest landmark protocol, and gradually we will add more landmarks. So you can see here the more extended one, in which we have added also landmarks on the teeth and on this region here, the basioccipital, etc., or the zygomatic. The problem is that we don't have too many complete skulls because we are currently gathering skulls from all over Africa, and it's not very easy to find complete ones. So as you can see also in this one, the front part is broken. That's why we are a bit hesitant at first to add a lot of landmarks, because we need to see in our complete data set what structures are available all over. This is another example. This is the most diverging one, male with the more extended data set. So there are 3 curves and a lot, like 25, I see, points. So that's more or less our protocol for the moment. And we can see even from these baby steps that we have made and our restricted data set that we have some promising results. I think that the main advantage of Checkpoint is that it's very easy. So it offers a very handy environment. Every command or every option is very clear and very easy. And as far as we've worked, there are no bugs in comparison to other software where sometimes you face some technical problems that you shouldn't have. So it's a very reliable and easy tool that can very quickly do whatever you want to do with simple geometric morphometrics, at least. And it's also important that it's not a very heavy program, in the sense that it doesn't require a supercomputer to work, while other software is a bit, more difficult. So yeah, for the moment it has worked great. To be honest, it's that simple. I mean, it's the easiest and most reliable tool that we found. We went through a series of comparisons with a lot of different software, and we have concluded that this is the best